Welcome to Thuma Mina Teaching. This is your 5th grade 9 Natural Sciences lesson for term 2. Today we will discuss the reaction that occurs between acids and bases. Specifically, we will look at neutralization reactions as well as the reaction between an acid and a metal oxide. Writing facts down helps us to remember them, so keep a pen and notebook ready. Today our key term is ion. Ions are particles that contain an electrical charge. Charges can be either positive or negative. Our first topic today is a neutralization reaction. But before we dive in, let us quickly revise what a neutral substance is. Neutral substances do not have any alkaline or acidic properties. They present with a pH value of 7. When an acid and a base combine, they will react together. The acid could make the base less alkaline, therefore lowering the pH, whereas the base would make the acid less acidic by increasing the pH value. This means that an acid and a base can neutralize each other's properties. This type of reaction is known as a neutralization reaction. These two substances have the ability to do this because a base contains negative ions in the form of hydroxyl groups, and acids have positive ions in the shape of hydrogen atoms. Acids and bases cancel out each other's properties when the hydroxyl group and the hydrogen group of the two compounds join together. When a base reacts with an acid, it becomes less alkaline. The pH lowers. The solution will have a much lower pH than that of the original base that was used. And when an acid reacts with a base, it becomes less acidic. Therefore, the pH will increase. This means that the resultant pH value of the solution that will form will have a much higher pH value than that of the original acid that was used. When an acid reacts with a base, the product that forms is usually a salt. In chemistry, we define a salt as a compound that forms after an acid reacts with another substance, whereby the hydrogen atoms of the acid are displaced with metal atoms. In the laboratory, we usually dilute acids and bases as they could be dangerous in their concentrated state. Can you remember what we call particles that contain a positive or a negative charge? Particles become ions when they are charged positively by losing electrons or negatively by gaining electrons. What do you think happens to the pH of Handy Andy if we were to add vinegar to the solution? Handy Andy is a base with a pH far above 7. When we add an acid such as vinegar with a low pH, the pH of Handy Andy will be much closer to 7. Are you able to classify what type of reaction occurred? When acids and bases react together, we call these type of reactions a neutralization reaction. What general products form after an acid and a base react? Or what general products form from a neutralization reaction? The products that formed are called a salt and water. Let's head over to High School Stellenbosch where Ms. Lampracht will demonstrate a neutralization reaction.
In this reaction, I will be demonstrating the neutralization of an acid and base. When an acid and base reacts with each other, it forms a salt and water. I decided to use diluted hydrochloric acid. Hydrochloric acid is safer to use diluted than when concentrated because it can cause serious burns to your skin when it comes in contact. The hydrochloric acid will be added to the burette. A burette is used when doing a neutralization reaction because this reaction requires extreme precision and the end point can be reached by a single drop. Once the hydrochloric acid has been added to the burette, I take the sodium hydroxide and add it to the volumetric flask. The sodium hydroxide is a base. To be sure that we know when we reach the end point, I will add universal indicator to the sodium hydroxide to indicate that it's still a base. The dark purple color indicates a strong base. You will then add the hydrochloric acid to the sodium hydroxide by using the burette and opening the tap to let acid enter the base dropwise. The hydrochloric acid and the sodium hydroxide are now performing a neutralization reaction. It is very important to stir your solution to ensure that the hydrochloric acid spreads equally through the base. Our color change to green has taken place. The solution has now been neutralized.
Let's do a quick recap on this experiment by answering a few questions. Can you remember why we used diluted hydrochloric acid instead of the concentrated hydrochloric acid? It is safer to use diluted hydrochloric acid as concentrated hydrochloric acid is extremely corrosive and can cause serious burns on the skin. What purpose does the burette serve in this experiment? It allows us to work with great precision. In this reaction, the end point, or the point at which neutralization occurs, can be determined by a single drop, and the burette allows us to do that perfectly. When we added the universal indicator to sodium hydroxide, what color change could you observe and why? The color change that we observed was a clear to a vibrant purple color. Sodium hydroxide is a base and it will turn purple in the presence of a universal indicator. Why do you think it was important to stir the mixture continuously? This is to ensure that the hydrochloric acid spreads evenly throughout the solution, and this is what we call diffusion. Can you remember the color change that occurred when we reached the end point or the point of neutralization? The purple color of sodium hydroxide turned into a light green color. Do you know what this color signifies? When we observe the green color, we now know that the sodium hydroxide, a base that had a base-like property and pH, has been neutralized, and therefore the pH will now be 7. Now, when you hear this, do you think that the new pH of our solution is higher or lower than the initial pH of the sodium hydroxide? Again, sodium hydroxide is a base and has a pH far higher than 7. The green color indicated that it is now a neutral substance of a pH of 7, and therefore the pH of the substance has dropped. So we've mentioned that the pH of the resultant product will be either higher or lower than the initial reactants. The pH value of the resultant product greatly depends on the pH value of the acid and base that I used in my experiment. The two most commonly used acids in the laboratory is hydrochloric acid and sulfuric acid. When these acids are concentrated, they pose extreme danger. We can dilute the strength of the acid by using a small amount of the acid and diluting it with 4 times the amount of water. When we dilute the acid, it becomes less concentrated. In our previous lesson, we learned about non-metal oxides. The ones we specifically paid attention to was carbon dioxide and sulfur dioxide. Now you will remember that these two compounds made up acid rain. When they dissolve in water, the solution becomes acidic. We also learned about metal oxides, the main topic for this lesson. We investigated the formation of iron oxide and magnesium oxide. These two substances are alkaline in nature. When dissolved in water, the pH value of the substance is generally above 7. So let us investigate the general reaction between an acid and a metal oxide. Remember, a metal oxide forms when a metal reacts with oxygen, such as iron reacting with oxygen to form iron oxide. When an acid reacts with a metal oxide, the products that form are water and a salt. Therefore, the general equation would be an acid plus metal oxide, the arrow to show that a chemical reaction is taking place, salt plus water. So let us look at a practical example. If magnesium oxide were to react with diluted hydrochloric acid, the products that we expect to see would be water and magnesium chloride. The salt that forms during this reaction is the magnesium chloride. The hydrogen atom that formed part of the hydrochloric acid was displaced by the magnesium atom, which is a metal atom. Now that you've seen the word equation for this reaction, use your previous knowledge and attempt to write the chemical equation for this reaction. Here is the correct chemical equation. You will notice that this equation is not balanced. On my left-hand side, I only have 1 hydrogen and 1 chlorine atom. But on my right-hand side, I have double the amount. In lesson 2, you were taught how to balance equations. Use those skills and attempt to balance this equation. If you find that you are struggling, have another look at lesson 2. If you added a 2 in front of the hydrochloric acid on your left-hand side, you are 100% correct. Now there are equal amounts of hydrogen and chlorine atoms on both sides. Let's see whether you've grasped what we've done so far by going through a few questions. Which two compounds, when dissolved in water, make up acid rain? It is the two non-metal oxides that are so popular, carbon dioxide and sulfur dioxide. When non-metal oxides dissolve in water, will the product have a higher or lower pH than 7? The pH will be lower than 7 because when non-metal oxides dissolve in water, they become acidic. We have now discussed non-metal oxides, but what happens when a metal oxide dissolves in water? Do you think that the pH of the water will be higher or lower than 7? Metal oxides, like magnesium oxide, tend to become alkaline in the presence of water and therefore will have a higher pH than 7. Which two products form when a metal oxide and acid react with one another? The two products that form are a salt and water. Let's head over to High School Stellenbosch, where Ms. Lamprecht will determine the pH of a metal oxide by using water as a control.
In this experiment, we will be determining the pH of a metal oxide. In order to do this, we first need to prepare a solution. Today, we have lithium oxide, which I will use to make a solution. The lithium oxide powder is added into a beaker and then water is added. You simply use the powder and then you add water. Once everything is added together, you can swirl your solution around in order for the lithium oxide to dissolve completely. In order to do any scientific experiment accurately, we need something to compare it to. So we will be using the lithium oxide as well as water to determine the pH. We will use the universal indicator and first add universal indicator to the water to make sure that our universal indicator is accurate, and then we will add it to our lithium oxide to determine the pH. I have 2 test tubes prepared. So in test tube 1, I will add the water, and in test tube 2, I will add the lithium oxide. I will add 1 drop of universal indicator to the water. The universal indicator takes a while to move through all the water particles, but once it reaches the bottom, it's clear to see that it turns green. Green indicates that water is a neutral substance and has a pH of 7. We will now add the universal indicator to the lithium oxide solution. Because we have a rather large volume of lithium oxide, we might need to add a bit more. The lithium oxide clearly changes purple. The purple color of the lithium oxide indicates that it is a base. Bases have a pH between 7 and 14 on the pH scale.
Let's test to see if you understand the different elements of the lab experiment that we've just watched. Why did we swirl around the liquid after adding water to the lithium oxide? This is to ensure that the lithium oxide dissolves completely and evenly spread out throughout the mixture. You'll remember that this is called diffusion. What is a control in an experiment? A control, and in this experiment our control was water, serves as a measure to which we compare our results. Which indicator did we use in our chemical experiment, and why do you think this was the most appropriate indicator to use? The indicator that was used is called an universal indicator. It is the preferred indicator to use because of its accuracy. Not only does it indicate whether a substance is an acid, base, or a neutral substance, it also tells us the exact pH by means of a color change. After adding the universal indicator to the water, we observed a color change from clear to green. What do you think that this means? This indicated that water is a neutral substance with a pH of 7. Was there a color change after adding the universal indicator to the lithium oxide, and what color change did you observe? The solution changed from a cloudy white to a very vibrant and deep purple hue. What do you think this color change indicates? The color change to purple indicates that lithium oxide is a base, and it has a pH far above 7. Now let's see if you have the knowledge to answer the following questions. This marks the end of the lesson. Please remember to complete the self-marking assessment, and I'll see you next time.
We hope you benefited from this video lesson. Our vision at Thuma Mina Teaching is to accelerate access to quality education. And our dream is to see learners across South Africa flourishing academically. We are a non-profit company and we are entirely dependent on public support. We produce lessons at the rate at which they are funded. As soon as a lesson is funded, it is published to the entire growing audience of Thuma Mina Teaching. Please consider taking hands with us in one of the following ways. Share our content with others that can benefit from it. A great way to support us is to find us on My School and to add us as your beneficiary. And consider donating towards a lesson, or ask your company's CSI department to partner with us. We are a PBO, so your donation is tax deductible. Our contact details you'll find on our website www.tmteaching.co.za. If you want to reach out to us, please email us on admin@tmteaching.co.za.